for this problem, I decided to use linear regression, and the rationale for that is that we have time series data. We're trying to predict precise values. So I knew that we weren't trying to do something like logistic regression to categorize data or unsupervised learning. And then I decided to do this in Excel as well. And so the first thing I did is I took the data and I randomized it. And then I also divided this into kind of the observations that I wanted to use for training and then an eval set. And so effectively I wanted to take that eval set, ensure that it was like randomly sequenced and kind of set that to the side, and we'll use that at the end. I then divided the kind of observations that we're going to use for training and divided that into 5 different folds. And so that's what you see here in column H. And then you can see across the tabs at the bottom that I've taken 4 of the folds, kind of the different combinations of the 4 different folds, and actually ran the regression across those combinations, and then used the fold that's left out to help calculate root mean squared error. So I ran 2 different regression models for each of these. The whole purpose of this is that we're trying to evaluate, well, which model is the best one for our data. So the first regression model I ran was just against temperature. I kind of figured that temperature was going to be our biggest predictor. Kind of wanted to understand, well, how much better is using temperature, pressure, and humidity versus just using temperature. I'll call out that I excluded using exhaust in all of these, exhaust in all of these. And the rationale for that is really just I'm trying to understand the type of problem we're solving for. I interpreted this problem to be, we might have a 10-day weather forecast or something like that and want to predict the amount of energy that we might use. And so I wanted to leave out exhaust because that's more a product or like an outcome of the energy that we use. And we wouldn't necessarily know that in advance, whereas we might have predictions as to how much or what the weather might be like. And so, yeah, I ran these 2 different regression models across each of the different combinations of folds, used the validation fold or kind of the remaining fold to do the validation. You can kind of see that across each of these tabs. And what you end up with is the root mean squared error for each model across each of the different validation folds. And what we see is that if you take, kind of the simple average across these, that we get a lower root mean squared error for model 2. And this is what we would have expected, that kind of having additional variables increases the predictive power of our model. But, kind of also notably only by a little bit. And so I took model 2 then, we've kind of done our analysis between, well, let's compare different models and select the best one. And I then finally kind of did validation or ran this against the eval set. And this is where we can kind of finally see how well our model performed against, new data. And what we get is an adjusted R squared of 0.92. So effectively 92% of the variability is accounted for by our model, which is pretty good. And then you can kind of further see from the coefficients kind of how each of these different variables contributes to the overall energy output. And I would just kind of call out that, as we somewhat understood and predicted and then sort of saw when evaluating these 2 different models, that temperature is kind of has a bigger impact here. And yeah, so high-level summary is that we took the data, we randomized it, we divided it into an eval set and 5 different folds. We ran kind of our 2 models that we wanted to compare across the different combinations of those folds and used the remaining fold to help calculate root mean squared error. We then calculated the average root mean squared error across the different folds, identified that model 2 was better. And then we took model 2 and kind of got output summary statistics on it with this eval set. And that's how I went about doing this problem.